Good afternoon, viewers of the DP Labs channel. My name is Kirill, and today we are testing a battery. We have put together a system to thoroughly test our batteries so that we can collect data, determine their capacity, and better understand their physical properties and operational characteristics. Essentially, it is a coil that is placed inside a water tank. In this setup, water flows through the system. Water comes in from the well and then goes back out into the sewer. When voltage is applied, the water gradually heats up, and as a result, the battery is loaded. In this way, we are able to determine how many amps it can deliver, to what temperature the battery itself heats up, how much it expands, and other important parameters that we need. These are clamp meters for 600 amps of direct current and a thermal imager. This is necessary for us to understand the currents flowing here, to understand what the temperature is on the battery, the incoming liquid, the outgoing liquid, and inside the reservoir itself. And accordingly, the most important parameter is how hot the battery gets under prolonged load, since this is important for its operational characteristics. Now we turn on the battery, and as a result, the load begins to start up and the contactor is triggered as well. At this moment in time, we have a current of 358 amperes, and the battery is sagging under the load, but that is completely normal in this situation. The inlet temperature is about 13 degrees. The outlet temperature is starting to heat up gradually, and as you can see, it's just now beginning to rise, indicating the initial stage of an increase. You can clearly observe the outlet temperature in the upper corner. The contactor is heating up. A large current is passing through. The wires are 50 square millimeters of copper. They are also, as you can see, heating up pretty quickly and noticeably. The current continues to stay at 350 amperes. There you go. The tests were successful. The resistor is done for. So today we didn't finish the test because the resistor was also our test subject today, and the test subject left the chat much earlier than we finished the test. So we'll fix the resistor. That's normal. We fully expected such a reaction. It's a big battery, 3P, so nothing surprising. We'll fix it, improve it, and be able to continue the tests. Our main battery is 2P. It fits into the quad bike, and the 3P is for maximum load. That's why we connected it, to put maximum load on the resistor. Since the resistor couldn't handle the load, we'll work on resolving this issue. Once we successfully eliminate the weak link, we'll be able to accurately record the battery heating readings, thoroughly test our other batteries, and provide you with all of this important data in the next part of the episode. So we continue testing the battery and the resistor. At the beginning of the video, it broke. 2 coils short-circuited and burned out. Now the coils have been fixed, rewound, limiters are in place, everything is precise. Now our resistor is working properly and fully ready for testing. Next, we move on to testing the battery, since everything is clear with the resistor now. We're applying a load now and the heating has started. Accordingly, we'll be monitoring the readings on the instruments. Next, we just wait and watch how the batteries heat up, how the wires behave, and how the water heats up. And we stand around observing all these mesmerizing things. The first weak point has been found. Our 50 square millimeter copper wires are starting to heat up at the crimping points. The temperature is high, already going over 100 degrees. Well, let me see. It's been After 20 minutes, the voltage is now at 83 volts and the electrical load is currently 306 amps. The wires have heated up, but they're not sized properly for the current here and will be replaced in the future. The battery is currently at 38 degrees Celsius, which is absolutely not critical for these cells. It's 36 degrees on the outer cells. So this is a perfectly normal operating temperature. The pieces of tape here are used so that the thermal imager can measure the temperature. It can't measure on reflective surfaces. That's why the tape is applied. 38, 37. In the middle part of the battery, which has the highest heat capacity, it's 38 degrees. That's it, and the wires have heated up, but that's normal. Next, we disconnect the load. Now we switch the load wires to our converter from high voltage to 12 volts, and we'll run tests with it. Whoa, that was really unexpected. I did not see that coming. Look, it just exploded, see? Well, you know, actually, I mean, to be honest, they... all of them, just a little more and they'll all go. Well, that's it, that's the test. So, as you can clearly see, the tests were indeed successful. The capacitors on our converter unfortunately exploded. A current of 50 amps sustained throughout ran for approximately 15 minutes, and then a significant reaction occurred, the consequences of which you saw in the previous footage. This is a normal story, which means we did everything right. We loaded it, understood its limits, now we know how to fix it, and accordingly we will fix it in the future so that this problem won't affect our customers anymore. And once we've fixed it, we'll definitely run more tests. The battery was smoking, but it wasn't anything serious. The smoke wasn't actually coming from the battery itself. It's just that the converter is installed inside the battery, so when the capacitors blew, smoke came out. In other words, nothing particularly dangerous happened. But again, we've gained some experience from this, and most likely in the future we'll move the electronic components outside the battery case, simply for convenience so that we don't have to unscrew a large number of bolts like we do now when disconnecting them. Everything's fine, the situation is clear, we're cleaning up the aftermath and getting ready to continue the tests. To make sure you don't miss it, stay tuned to the Deep Labs channel, subscribe, like, leave comments, and look forward to new episodes. See you soon.